Hello students, in this video we are going to discuss the topic of differential equations. Let's start with the first of all basic introduction. The definition of differential equation: an equation which expresses a relation between dependent variable, independent variable and their derivatives of any order is called differential equation. For example, look at this example: dy by dx is equals to 3x square y cube. So this is a representation of a differential equation. You can see here the variable y is dependent and it is dependent on variable x. And similarly, there is one more example which contains the derivative of order 2, d square y by dx square plus x times of dy by dx plus y is equals to 2 sine x. So in general, we can say, let's say f is a function of x, y and all the other derivatives of any order, like a first order, second order or in general nth order. So any expression of this form is known as differential equation. डिफरेंशियल इक्वेशन में क्या होगा हमारे पास, लेट्स से अगर हमारे पास एक वेरिएबल है y, देयर इज अ वेरिएबल y which is dependent and it is dependent on variable x, which means x itself is independent. Now rate of change of y with respect to x is defined as derivative, that is dy by dx. Then this is second order derivative, third order derivative and so on. Now any equation which will be consisting of this y, the dependent variable, independent variable and their differential coefficients, or you can say the derivative, is known as differential equation. For example, you can say, let's say I am choosing dqy by dx cube plus x square y is equals to tan x. So this is a representation of differential equation which contains the dependent variable y, the independent variable x and a differential coefficient. An equation can contain one differential coefficient, it can contain more than one differential coefficient, it can be of any type, and this is the general form. The next term we have is order of differential equation. The order of differential equation is the order of highest order derivative occurring in the equation. जो highest order derivative present होगा उसका जो ऑर्डर है वही हमारी डिफरेंशियल इक्वेशन का क्या हो जाएगा, ऑर्डर हो जाएगा. अब जैसे अगर आप यहाँ पे देखो, कंसीडर दिस फर्स्ट एग्जांपल डी स्क्वायर वाई बाई डी एक्स स्क्वायर प्लस डी वाई बाई डी एक्स प्लस 3y इज इक्वल्स टू 0. हाईएस्ट ऑर्डर डेरिवेटिव टर्म कौन सी है जिसका हाईएस्ट ऑर्डर हो, द फर्स्ट वन ना, डी स्क्वायर वाई बाई डी एक्स स्क्वायर, डी स्क्वायर वाई बाई डी एक्स स्क्वायर, ऑर्डर कितना है 2. सो द हाईएस्ट ऑर्डर डेरिवेटिव भी 2 हो गया. So is the order of differential equation, वो भी कितना हो गया, order of differential equation is 2. Similarly, look at this example, this is dy by dx raised to power 3 equals to 4y. ये भी एक differential equation की example है. अब इसका order कितना होगा, देखो डेरिवेटिव का ऑर्डर कितना है, यहाँ पे 1 है, ये उसकी पावर है बच्चे. दिस 3 इज द पावर ऑफ दिस डेरिवेटिव. द ऑर्डर ऑफ डेरिवेटिव इज स्टिल 1 ना, डेरिवेटिव का ऑर्डर तो 1 ही है, 3 नहीं बोलेंगे. सो द ऑर्डर इज 1, this is the power of derivative which is not the order. The next thing is degree of differential equation. The degree of differential equation is the degree of highest order differential coefficient after making the differential equation free from radicals and fractions and putting it in the form of a polynomial in its derivatives. मतलब हमने अगर कहीं पर हमारी इक्वेशन में लेट से कुछ इस टाइप की बनी हुई है, dy by dx square root is equals to xy. दिस इज ऑल्सो डिफरेंशियल इक्वेशन ना. अब यहाँ पे स्क्वायर रूट आ रहा है तो हमने क्या करना है, अगर हमने इसकी डिग्री कैलकुलेट करनी है, सो व्हाट वी हैव टू डू इज वी हैव टू रिमूव द स्क्वायर रूट फर्स्ट ऑफ ऑल बाय स्क्वायरिंग both sides. We will get like this. Now this is a differential equation, dy by dx is equals to x square plus y square. अब हम डिग्री कैलकुलेट करने की बात करेंगे. जब तक हम ये जो पावर्स आ रही हैं, फ्रैक्शंस हैं, रेडिकल्स हैं, इनको ख़त्म नहीं कर देते, उससे पहले हम डिग्री की बात नहीं कर सकते हैं. पहले हमें इक्वेशन को सिंप्लीफाई फॉर्म में बनाना पड़ेगा. नाउ लुक एट दिस इक्वेशन, डी स्क्वायर वाई बाई डी एक्स स्क्वायर प्लस डी वाई बाई डी एक्स प्लस 3y इज इक्वल्स टू 0. नाउ वट इज़ द हाइएस्ट ऑर्डर डेरिवेटिव हियर, हाइएस्ट ऑर्डर डेरिवेटिव फिर से कौन सा है, डबल डेरिवेटिव डी स्क्वायर वाई बाई डी एक्स स्क्वायर. उसकी पावर कितनी है, द पावर इज 1, इट मीन्स द डिग्री इज 1. डिग्री है क्या, जो हमारी इक्वेशन में हाईएस्ट ऑर्डर की डेरिवेटिव की टर्म होगी उसकी पावर कितनी. लुक फॉर द degree of, or you can say power of, highest order derivative term present in your equation. Now at this second example, if you look at this second example, this is dy by dx raised to power 3 is equals to 4y, and the degree is going to be obviously 3. Now if you look at this example, this is y is equals to x dy by dx plus 1 by dy by dx. Now from here we can't simply say the degree is 1 because the power of dy by dx is 1. No, first of all we have to do the necessary simplification. After doing the modifications, then we will calculate the degree. तो हमने यहाँ पे क्या करा है, we just simplified this equation. We get y dy by dx is equals to x dy by dx whole square plus 1. Both sides हमने क्या करा है, we multiplied the equation both sides by dy by dx. Now look at this equation, and from here you can see the degree is 2 because there is only first order derivative term present here and its degree is power is 2. So corresponding to that, the degree of our differential equation is also 2. The next important definition comes out to be is linear and non-linear differential equations. Very important definition, that what is a linear differential equation and what are non-linear differential equations. So let's check now. A differential equation is said to be linear if the dependent variable and its derivatives occur only in first degree and are not multiplied together. क्या कंडीशंस है हमारे पास? इन टोटल देयर आर 3 कंडीशंस that the dependent variable, let's say y is dependent variable here, the dependent variable and the differential coefficients like dy by dx, d square y by dx square, dq y by dx cube and so on, जितने भी ऑर्डर का हमारे पास इक्वेशन में डिफरेंशियल कोफिशिएंट है, all of them should be of डिग्री 1. इन सभी की कोई भी पावर नहीं होनी चाहिए एक्सेप्ट 1. लीनियर होने चाहिए ये सभी हमारे पास टर्म्स जो है. सेकेंडली, दे शुड नॉट बी मल्टीप्लाइड टुगेदर. वाई किसी डेरिवेटिव के साथ मल्टीप्लाई में नहीं पड़ा होना चाहिए, या कोई भी दो डेरिवेटिव टर्म्स हैं जो वो मल्टीप्लाई में नहीं होनी चाहिए. इफ ऑल दिस कंडीशंस आर सेटिस्फाइड देन वी से द इक्वेशन इज लीनियर. अदरवाइज अगर एक भी कंडीशन फेल हो जाती है, अदरवाइज द इक्वेशन इज सेट टू बी नॉन लीनियर. लेट्स लुक एट दिस एग्जांपल नाउ. d square y by dx square plus y is equals to sin x. Now if you see, the power of y is the dependent variable 1. Okay, the power of derivative it's also 1. देखो ऑर्डर 2 है डेरिवेटिव का, नो प्रॉब्लम, बट उसकी जो डिग्री है, पावर है, वो तो 1 है ना. सो द ऑर्डर ऑफ डेरिवेटिव इज 1, ऑर्डर ऑफ डिपेंडेंट वेरिएबल इज 1 एंड नन ऑफ देम इज मल्टीप्लाइड. कोई मल्टीप्लिकेशन भी नहीं है. सो दिस मीन्स दिस डिफरेंशियल इक्वेशन इज linear and its order is 2 with degree 1. Now look at this second example. This is also differential equation y dy by dx is equals to x. Now see, the degree of y is 1, okay. The degree of the differential coefficient is 1, okay. But what about the third condition? The dependent variable and the differential coefficient, they are multiplied. जो बच्चे हमारा y है और जो डेरिवेटिव है, दोनों मल्टीप्लिकेशन में आ गए. It means condition fail हो गई. So this equation is non-linear because y and dy by dx are multiplied together. Similarly, let's have a look at this third example now, which is dy by dx whole square plus y is equals to x square. बच्चे देखो ये टर्म क्या रिप्रेजेंट करें, इन दोनों का डिफरेंस समझो. सी, दिस इज द सेकेंड ऑर्डर डेरिवेटिव टर्म with degree 1, or you can say power. This is the first order derivative term with power 2. अब डेरिवेटिव जो डिफरेंशियल कोफिशिएंट उसकी पावर आ गई है, वो भी 2. इट मीन्स दिस इक्वेशन इज ऑल्सो नॉन लीनियर बिकॉज वी वांट दैट द डिफरेंशियल कोफिशिएंट्स शुड बी ऑफ फर्स्ट डिग्री. I hope this definition is clear as this is important one, linear and non-linear differential equation. Now coming to other part, the next definition is ordinary differential equation and the second one is partial differential equation. A differential equation involving derivatives with respect to a single independent variable. जब हमारे पास क्या होंगे, हमारे पास इस तरह की इक्वेशन है जिसमें वन इंडिपेंडेंट वेरिएबल है एंड वन डिपेंडेंट वेरिएबल है. मतलब एक ही वेरिएबल है y विच इज़ डिपेंडेंट ऑन x. तो यहाँ पे डिफरेंशियल कोफिशिएंट्स क्या होंगे, dy by dx, d square y by dx square and so on. So one dependent variable on one independent variable. Such equations are termed as ordinary differential equations. In short, you can say ODE. and you can just give any example of such equation, like here d square y by dx square plus 2 dy by dx plus 4y is equals to e raised to power x. But on the other hand, the partial differential equations are those which involve partial derivatives with respect to more than one independent variable. अब जब हमारे पास क्या होगा कि डिपेंडेंट वेरिएबल है, जो द डिपेंडेंट वेरिएबल is dependent on, when the dependent variable is dependent on more than one independent variable. अब जो independent variables है वो एक से ज़्यादा हो गए. Like you can say there is a variable z which is dependent on x as well as y. Now there is one dependent variable depending on two independent variables x and y. So here the concept of partial derivatives will come play. Will role play na, curl z by curl x and curl z by curl y. Now a differential equation which will involve partial derivatives, that is known as partial differential equation. We can have a look at this example. Curl square u by curl x square plus curl u by curl y is equals to 0. Now this equation has one dependent variable u dependent on variables x and y containing partial derivatives. So this equation is termed as PDE, that is partial differential equation. Clear? Now moving to the other part, which is also again an important aspect, which is solution of differential equation. Solution of differential equation. So a solution of a differential equation is a relation between the variables involved which satisfy the given differential equation. मतलब let's say हमारे पास एक equation है जिसमें y dependent variable है and x is the independent variable. तो एक जो relation होगा हमारे पास y और x के बीच में, relation between y and x, जो given differential equation है उसको क्या करेगा, satisfy करेगा, that is going to satisfy the given differential equation is known as the solution. Let's have a look at one example. Consider there is a differential equation dy by dx plus 1 is equals to 0. This is a first order, first degree linear differential equation where y is dependent variable and it is dependent on x. Now consider y is equals to minus x. Now you can see this is the relation between y and x, and if I, from this value, if I calculate dy by dx, it will be minus 1. Put this value in equation 1, what you get? Minus 1 plus 1, 0, which you get the right hand side satisfied. It means this relation satisfies the given differential equation. This relation between y and minus x, which is y is equals to minus x, satisfies the given equation. It means this is solution of above differential equation. तो ये इसका क्या हो गया, सोल्यूशन हो गया. मतलब जो रिलेशन डिपेंडेंट और इंडिपेंडेंट वेरिएबल में होगा और वो इक्वेशन को सेटिस्फाई भी कर रहा है, तो उस रिलेशन को हम क्या बोलते हैं, व्हाट वी कॉल दैट, सोल्यूशन ऑफ गिवन डिफरेंशियल इक्वेशन. नाउ सी इन द सेम प्रॉब्लम, for the same one, if I choose the value of y like this, minus x plus c, where c is a random constant, where c is an arbitrary constant. If I choose y is equals to minus x plus c, then dy by dx is again derivative of x is 1, constant 0, it is minus 1, which is also satisfying equation 1, which is satisfying equation 1. It means this is also the solution of equation 1. तो ये भी solution हो गया, y is equals to minus x plus c, right? This is also the solution of equation 1 where c is the arbitrary constant. Now there are two different categories of a solution. The first one is general solution. A solution of differential equation is said to be general solution if it contains as many arbitrary constants as is the order of equation. अब आपके पास एक equation है, उसका आपने सोल्यूशन कैलकुलेट कर लिया जिसमें आर्बिट्ररी कांस्टेंट्स भी आ रहे हैं, है ना. अगर उसमें जो काउंट है आर्बिट्ररी कांस्टेंट्स का और जो आपकी इक्वेशन का ऑर्डर है वो मैच कर जाता है, दे आर इक्वल, देन दैट सोल्यूशन इज नोन एज जनरल सोल्यूशन. फॉर एग्जांपल सी दिस, व्हाट इज द ऑर्डर ऑफ दिस इक्वेशन, 1. How many constants are here in this solution, 1. So the number of constants is same as the order of this equation. It means this solution can be termed as जनरल सोल्यूशन. तो ये सोल्यूशन हमारा क्या हो गया, जनरल सोल्यूशन हो गया. एंड ऑन द अदर हैंड, अ सोल्यूशन ऑफ डिफरेंशियल इक्वेशन इज सेड टू बी पर्टिकुलर if it is obtained from general solution by giving particular values to the arbitrary constants. अब आप क्या करो, जनरल सोल्यूशन में जो आर्बिट्ररी कॉन्स्टेंट्स आ रहे हैं उनको पर्टिकुलर वैल्यूज असाइन कर दो, तो जो आपको वो सोल्यूशन मिल जाएगा दैट इज गोइंग टू बी पर्टिकुलर सोल्यूशन. जैसे यहाँ पे if I assign c to be 0, what you will get, y is equals to minus x. This is also solution of equation 1, and this solution is termed as particular solution. तो जनरल सोल्यूशन कौन सा हो गया, जनरल सोल्यूशन इज दैट वन विच कंटेन्स एज many constants as is the order of equation, and a solution which is obtained from general solution by assigning values to arbitrary constants is known as particular solution. जो particular solution होगा उसमें या तो arbitrary constants होंगे ही नहीं, अगर होंगे तो जितना हमारा order है equation का उससे कम होंगे. Okay, remember this. General solution contains same constants as the order of equation. Particular solution contains arbitrary constants less than the order of differential equation. Either there will be no arbitrary constant in the particular solution, or if it is there then they are going to be less than the order of the differential equation. Let's have a look at one example to get a clarity about the topic solution, right? Now the question is, check whether a relation which is given by x is equals to a cos nt plus alpha is the solution of this given equation. The equation given is d square x by dt square plus n square x is equals to 0. If you see here, x is the dependent variable and it is dependent on the variable t. तो ये सेकंड ऑर्डर की इक्वेशन दे रखी है हमें. दिस इज अ सेकंड ऑर्डर डिफरेंशियल इक्वेशन एंड वी हैव टू वेरीफाई वेदर दिस इज सॉल्यूशन और नॉट. हाउ वी आर गोइंग टू वेरीफाई दैट? What we will do, we will see whether this relation satisfy the given equation. हम ये चेक कर लेंगे क्या अगर ये वैल्यू हम इस इक्वेशन में पुट करें उसको सेटिस्फाई कर रहा है. नाउ given differential equation is this one. Also given x is equals to a cos nt plus alpha, where alpha and a are the constants. Now from equation 2 we will calculate d square x by dt square by differentiating it twice. We are going to differentiate this equation number 2 two times. So what you will get here, d square x by dt square. You can do the differentiation by yourself. I am not going in detail about that part. So the double differentiation gives the answer minus a n square cos nt plus alpha. Remember that a and alpha both are constants and we are differentiating with respect to t. Now see, this is a cos nt plus alpha. It's again regenerated as x. So it means d square x by dt square is equals to minus n square x. Put this value from equation number 3 in equation number 1. What you get? Minus n square x plus n square x equals to 0. It means left hand side is equals to right hand side. So satisfied. It means x is equals to a cos nt plus alpha is the solution of equation number 1. So this was all about that how we can check whether a given function is solution or not. Now let's discuss more about this. Now see, in the equation number 2, which is x is equals to a cos nt plus alpha, how many arbitrary constants are here? The arbitrary constants a and alpha, two constants are here. Okay, which are 2 a and alpha. And what is the order of differential equation given to us is, see the order 2, number of arbitrary constants same as the order. It means this solution is the general solution of our equation 1. If you look at this now, if we see x is equals to a cos nt plus 5, that is I have assigned a value 5 to alpha. अल्फा को क्या वैल्यू असाइन कर दी हमने 5. या खुद से चेक करके देखना, जस्ट गिव इट अ ट्राई दैट दिस इज आल्सो द सॉल्यूशन ऑफ इक्वेशन नंबर 1. ये भी उसे सेटिस्फाई करेगा. बट नाउ द arbitrary constant is only 1 and the order of equation was 2. arbitrary constants एक ही है, ऑर्डर कितना था इक्वेशन का 2, कम हो गया, इट इज लेस देन द ऑर्डर. So this solution is known as the particular solution of the given equation. Clear? So this video was all about now the basic concepts of differential equation, the introduction. In the next video we will start working on the problems that how we can solve the various differential equations. कि अगर हमें कोई differential equation दे रखी है तो उनके हमने solutions कैसे find out करने हैं वो हम next videos में सीखेंगे. Okay, and let me know if you have any doubt in the definition part.